Today's lesson is on section 5.5, which is all about the trapezoidal rule. And we're going to calculate areas under the curve using trapezoids. And this makes sense since we've been using the rectangular area methods, left ram, right ram, and MRAM, midpoint ram. And we have found some accuracy using the rectangles. So now it makes sense that if we make, instead of a rectangle on a curve, a trapezoid, and remember the trapezoid area is equal to 1/2 height times base 1 plus base 2. So if we make a trapezoid, and remember we can have many trapezoids here between 2 points. So this would be our B1, this would be our B2, and these are actually the y-axis values of the function, and then our height is the interval. Okay, so the height times B1 plus B2. Now, some really smart people have put this into a formula using the y values of the function and using h. To calculate h, you take b minus a, which is the width of the interval, and divide it by n, the width of the entire interval, and divide it by the number of intervals you want, or subintervals is what they call it, n subintervals. Okay, so in this case we have 1, 2, 3, 4 subintervals, so n equals 4. That's supposed to be an n, not an h. And we'll make it bigger. N equals 4, and then the h would equal the b minus a over however many subintervals you have. Algebraically, some textbooks write this formula differently, and I think this tells you that the trapezoidal rule would make it more accurate. By the way, up here it says we're going to be learning Simpson's rule. Simpson's rule is not on the AP exam, so in fact we are not doing it. So let's do our first problem. Wait, I thought we had another problem. Oh, no, I guess we have the first problem right here. Use the trapezoidal rule with n equals 4 to estimate this integral. So remember, an integral sign is the area under the curve from 0 to 2. Okay, and n equals 4 means we're going to divide 0 to 2 into 4 intervals. Each of those intervals is going to be 1/2 wide, correct? Correct. So you could find that using b minus a, because remember this is a, this is b, a to b, over 4, and that means the intervals are 1/2. So mathematically, this is how you would find it. Geometrically, if you draw a picture, it makes sense. These heights are all 1/2. So the h number in your formula is 1/2. So t equals 1/2 over 2. You need an interval width to use this formula. Now we're going to have 4 different points along this path, or actually 1, 2, 3, 4, 5, and let's see. So we've divided that into 4 intervals. A to B is actually 0 to 2 in our case, and we found that h is 1/2. Okay, so now we're going to use this formula. It starts out with y at 0 plus 2 times y at 1/2 plus 2 times, I'm going to have to clean this up for just a second. Okay, back to where we were. Y at, oops, I don't need a parenthesis there. Y at 1 plus 2 times y at 3/2, or 1/2, plus y at 2. Big parentheses. Okay, so 1/2 over 2 is multiplied times this entire thing. This is using our equation for the trapezoidal rule. All right, now we just need to plug in values, what the y value is. Now, when we say y, we're looking at x cubed plus x in this case, even though y is actually equal to the integral of that. When we are looking at plugging in values, we're going to plug 0, 1/2, 1, 3/2, and 2 into this formula and see what we get. All right, so 1/2 over 2 is equal to 1/4. So we'll write 1/4. And let's write in the value at y of 0 is equal to 0 plus 2 times y at 1/2 is 1/2 plus, no, actually it's 1/8 plus 1/2 plus 2 times 1 plus 1 plus 2 times something plus 10. Okay, when I plug 3/2 in and cube it, I get 27 over 8 plus 1/2. Okay, plug this into your trusty calculator. And remember, we need to know how to do this by hand because you don't know if this might be a calculator or non-calculator question. All right, so this is what we get using the trapezoidal rule. Now let's take out our calculator and use Math 9 to see what we actually get when we use the integral. F-I-N-T is the same as Math 9, okay? That's how we used to have to do it before we got the integral sign on the calculator, and you guys are lucky. It's much easier now. Okay, so here is Math 9. And you plug in the values just like the equation looks and press enter. Well, we get a value of 6. So remember, the trapezoidal rule is an estimation. The true integral value, 0 to 2, is equal to 6. So just so you know, this is an estimation. Trapezoidal rule gives us an estimation. So it turns out to be an overestimation in this case. It could be either one for trapezoidal rule because it depends. Okay, very good. Next problem. This is a problem from your book, and it shows the picture of a pond, I think. And we are going to try to find out the number of fishing licenses you can issue for this. All right, so you should pause here and read the problem number 10, stocking the fish pond. You're the fish and game warden of your township. You're responsible for stocking the pond with fish before the season. The depth of the pond is 20 feet on average. Using a scaled map, you measure the distances across the pond at 200-foot intervals. Okay, 200-foot intervals, that is going to be your H, by the way. Also, you're looking for volume of the pond. So remember that volume equals area times the depth, okay, D-E-P-T-H. All right, this is the top of the pond. All right, that's what this is a picture of. This picture is also in your book. So the depth is 20 times the area. We're going to estimate the area using trapezoidal rule and using this picture. Okay, so one of the things it told us is that our H value equals, I just said it, 200. Okay, so in between each of these values is 200. All right, so that helps us out because we don't have to calculate 200. We have 200 over 2. That begins our formula, filling in our formula, which I have over here on the side for your reference convenience. All right, so this equation might get a little long, but that's okay. This is going to be our y at 0, and this is going to be our y at n at the end. All of these in between are going to be multiplied by 2. Okay, so we're going to have a 0 on one end, a 0 on the other end, And all the middle ones, according to our formula over here, are multiplied by 2. So we're going to have 0, if I start from the bottom and move up, we're going to have 0 plus 2 times 860 plus 2 times 1110 plus 2 times 1160 plus 2 times 1140 plus 2 times a grand plus 2 times 800 plus 2 times 540, or 520, sorry, plus 0. All right, now all of that needs to be multiplied by 200 over 2, or 100. All right, so do this on your calculator and see if the teacher is correct, but I get 1,318 feet squared. That is the area of the top of the pond. Now remember, the question was, what's the volume? So we're going to multiply that number is t times 20, and that would equal 26,360,000 feet cube, or cubic feet. All right, and that is the answer to part A. The second part of this question asks, you plan to start the season with 1 fish per 1,000 cubic feet. You tend to at least have 25 of the opening fish population left at the end of the season. What's the maximum number of licenses the town can sell if the average seasonal catch is 20 fish per license? This is a good typical AP type question too, makes you think. So first it says we're going to have 1 fish. So let's see how many fish we have first of all. We're going to take this number V and divide it by 1,000, because it said we're going to have 1 fish per 1,000. So we have this many fish, 26,360 fishes. All right, so then it says we want 25% left. That means we're going to allow the fishermen to catch 75% of the fish. So fish to be caught is 75% of this number. So 0.75 times 26,360. That says we have how many fish? We have, take out that trusty calculator, 19,770 fishies. All right, so if we let 20 fish per fishing license, we're going to divide this by 20 fish per license, and this is going to tell us how many licenses equals the number of licenses we can sell. I don't know if I spelled that right. Licenses. C-O. I don't think there's this S. That's a hard word to spell. Anyway, this says that you can sell 988 fishing licenses max. That's your maximum number. Okay, and that is that problem. Okay, so that is using the trapezoid rule in kind of a real problem. And I just want to mention one other thing and we're done with section 5.5. FYI, this is the Simpsons rule. Do not write this down. It's in your book if you want to, dream over it. Basically what it says, and I just want you to know that it exists. You will not be using it on your AP exam. It's on page 309 in your book. It uses a parabolic or curvy top on a rectangular figure. So it actually gives that area, like the area of something like this. So it's actually more accurate than the trapezoidal rule, but the trapezoidal rule seems to be more common and definitely is asked on the AP exam. So that's the end of chapter 5. Yahoo! We've got a chapter and a half to go.